So we're going to talk a little bit more today about area, and finding the area under a curve really is just the simplest type of finding the area of a plane region, which is a rectangle. So remember, a rectangle to find the area is just the base times the height. We can use rectangles to approximate the area of a plane region or under a curve. So let's say we have this curve here, and notice there are two ways I can draw rectangles under this curve. So the first way is what we call using the left side. So if I were to take the area under this curve from here to here, right, this whole area right here, and I break it into rectangles at even amounts, and then for each subdivision, I'm going to go over to the left-hand side of that subdivision, go up to the curve, and draw a rectangle. So from 1 to 2 here, I'm going to go over to the left-hand side, go up to the curve, and draw a rectangle. For this section from 2 to 3, I'm going to go to the left-hand side, go up to the curve, and draw a rectangle. Well, then I could actually calculate the area under that curve, and I would get an approximation. So here from 0 to 1, the area of that rectangle would just be the height times the width. So the height is 0, the width is 1. So that means this area is 0. Plus, we'll go to the next rectangle. So here I'm going up to the curve, right? My height is about 1, and my width is 1. So 1 times 1 gives me an area of 1 for this rectangle. Now I'm going to look at the third rectangle from 2 to 3. Go up here. My height is 2 and my width is 1. So the area of this rectangle is 2, which gives me an overall area of 3. But I also notice, if I zoom in really closely here, I'm missing some portion. Right? This is some area under the curve that I'm missing. So this actually gives me an under approximation. And let's take a look here. This is using the right end. So what that means is for each interval, I go over to the right, up to the curve, and come back and draw my rectangle. So from 1 to 2, I'll go over to the right-hand side, up to the curve, draw my rectangle. From 2 to 3, I go over to the right-hand side of the interval, go up to the curve, and draw my rectangle. So if we do that, let's take a look. In this first curve, or first rectangle right here, I've got a rectangle that's about a 1 by 1, so that gives me an area of 1. If I go to the next rectangle here, I have a height of 2, a width of 1, so 2 times 1 gives me an area of 2. And I'll go to the third rectangle here. If I go all the way up, right, that gives me about an area 4 times 1, which is 4. So if I add those together, I get an area of 7. And if we zoom in on this one, we see we've got some bits of area we've calculated that are over the curve. So using the right end gives us an over approximation. And the bottom line here is, if we think about this, and if we had infinitely many rectangles, meaning each width, right, change in x, you could think of this as your delta x, this as your delta x. If that approached 0, we can get a best approximation of the area. And this is going to lay the foundation for this idea of taking the limit as this width approaches 0.